Laplace transform. First of all, definition of Laplace transform. Let f from g to infinity to r be the function such that the integral (0 to infinity e raised to minus st f of t dt exists, then this integral e raised to infinity 0 to infinity e raised to minus st f of t dt is called Laplace transform. It is denoted by L of f of t or f bar s. Now we will show that f of t is 1, then L of f of t, that means L of 1 is what? We know that L of f of t is equals to 0 to infinity e raised to minus st f of t dt. Then L of f of t is 1. So L of 1 is 0 to infinity e raised to minus st f of t means 1 dt is equals to 0 to infinity e raised to minus st dt. Now integration e raised to minus st with respect to t is upon minus s 0 to infinity is equals to minus 1 upon s e raised to infinity minus e raised to 0. E raised to infinity is 0, e raised to 0 is 1. So minus minus plus, so 1 upon s. L is linear. That means statement alpha beta is in C, f and g are function defined on 0 to infinity to r, and L of f of t and L of g of t is exist, then prove that L of alpha f plus beta g of t is equals to alpha L of f of t plus beta L of g of t. Now alpha beta is in C and f and g are function defined on 0 to infinity to r. L of f of t and L of g of t is exist. Now alpha beta is in C and f and g are from 0 infinity to r, and L of f of t and L of g of t are exist. Now we will prove that this. So L of alpha f plus beta g of t is equals to, by definition of L of t, L of f of t is what? 0 to infinity e raised to minus st f of t dt. Now here f of t is alpha f plus beta g of t. So 0 to infinity e raised to minus st f of t means alpha f plus beta g of t dt is equals to 0 to infinity alpha e raised to minus st alpha f of t plus beta g of t dt. L of f of t and L of g of t is exist. So we can write this 0 to infinity e raised to minus st alpha f of t dt plus 0 to infinity beta e raised to minus st g of t dt. Now L of f of t and L of g of t exist, so we can write this e raised to minus st f of t dt plus beta 0 to infinity e raised to minus st g of t dt. And by definition, this is a definition of L of ft and this is the definition of L of gt. So alpha L of f of t plus beta L of g of t. Proved. Example, L of f of t is equals to c. C means constant. Then L of f of t means L of c is what? Now L of c is equals to L of, we can write c as 1 into c. C is constant, so c L of f of t, c L of 1, because L is linear. And we know that L of 1 is 1 upon s, so this is c upon s. So L of c is c upon s. Now f of t is t, then L of f of t means L of t is equals to 1 upon s square. Similarly, we can show that L of t is 1 upon s square. Similarly, we can show that L of e raised to at is 1 upon s minus s. We will show that f of t is t raised to n, then L of t raised to n is what? We know the formula of L of f of t is 0 to infinity e raised to minus st f of t dt. Now here f of t is t raised to n, so L of t raised to n is equals to 0 to infinity e raised to minus st f of t means t raised to n dt. Now we will suppose that st is x, then t is x upon s, so t means dt is 1 upon s x dx. Put this in this, so we get L of t raised to n is 0 to infinity e raised to minus st is x, so e raised to minus x, t raised to n, that means x, t means x upon s raised to n, dt means 1 upon s dx. Here 1 upon s raised to n into 1 upon s, then which is equals to 1 upon s raised to n plus 1. 0 to infinity e raised to minus x, x raised to n upon s raised to n plus 1 dx. Now 1 upon s raised to n plus 1, 0 to infinity e raised to minus x. We can write this as n plus 1 minus 1 dx. Which is equals to 1 upon s raised to n plus 1, and this means gamma n plus 1. Was formula gamma n is 0 to infinity e raised to minus x, x raised to n minus 1 dx. Here n is equals to n plus 1, so this is gamma n plus 1 is equals to gamma n plus 1 upon s raised to n plus 1. If n is natural number, that means all n is in n. If n is natural number, then L of t raised to n is n factorial upon s raised to n plus 1. If it is not natural, then we will use this formula gamma n plus 1 upon s raised to n plus 1. Basic formula of sin theta. We know that sin theta is equals to e raised to I theta minus e raised to minus I theta by 2 I. Cos theta is e raised to I theta plus e raised to minus I theta by 2. Theta is e raised to theta minus e raised to minus theta by 2. And cos hyperbolic theta is e raised to theta minus plus e raised to minus theta by 2. F of t is sin 80. Then we will show that L of f of t, that means L of sin 80 is what? Now L of f of t, L of sin 80 is equals to, by this formula, sin theta is this, then 80, theta is equals to 80, then e raised to I 80 minus e raised to minus I 80 by 2I L of, because sin 80 is equals to this, so L of sin 80 is equals to L of this. So 1 upon 2I L of e raised to I 80 minus e raised to minus I 80 is equals to 1 upon 2I L of e raised to I 80 minus L of e raised to minus I 80. We know that e raised to 80, we know that e raised to 80 is equals to 1 upon s minus a. So 1 upon 2I e raised to I 80 is equals to 1 upon s minus 80. Sorry, s minus 1 upon s minus minus I. So 1 upon 2I 1 upon 2I 1 upon s minus I minus 1 upon s minus minus I, minus minus is plus, so 1 upon 2I 1 upon s minus IA minus 1 upon s plus IA. Cross multiplication, we get n plus s plus IA minus s minus IA by s minus IA into s plus IA. So 1 upon 2I s plus IA minus s minus minus plus IA by, we know that a minus b, a plus b is equals to a square minus b square. So a square minus b square. Okay. So 1 upon 2i s minus s cancel out. Ia plus ia is 2ia upon s square minus I square s square. Now we know that I square is minus 1. So 1 upon 2ia divided by s square. This will be minus 1. So minus minus plus s square. Here 2i cancel out. So we get a upon s square plus s square. L of sin at is equals to a upon s square plus s square. Similarly, we can prove that L of cos at, L of sin hyperbolic at, L of cos hyperbolic at by above methods.